So welcome everyone again to the Green Era Hub webinar series. My name is Barry Crosby and I'm one of the communication officers for the Green Era Hub project. If you've been here before, you'll know that the Green Era Hub project officially started in September 2022 as a coordination and support action of the European Commission under the Horizon Europe programme. And it currently represents 15 EU ERANETs, co-funds and self-sustained initiatives in the field of agri-food and biotechnology. So we started these breakfast clubs here last year in October, and we've had 3 very successful series so far. The first one was circularity in agriculture. The second series was related to biotechnology to advance sustainable solutions for bioeconomy. And the one that we just finished was sustainable food systems. If you're interested in listening to the talks related to any of the topics in these series just mentioned, our recordings are now available to view on YouTube. Now, for these 3 months, we're focusing on the topic of precision agriculture technologies for a sustainable future. And here we're going to have topics related to transparency across the value chain of different products, application of artificial intelligence in farming, robotics in farming, among many others. And just a few housekeeping announcements. Please feel free to type your questions in the Q&A chat section, which I've enabled for everyone. I'm going to do my best to address as many questions as possible within that time that we have today, which is 1 hour. So if at the end of any of the 2 sessions you have a question for either of the speakers, please do remember to address the speaker in the question. Okay, so I'm just going to share my screen. Just 1 moment, please. Now, today we will have 2 panelists joining us, Dr. Sabrina Hempel and Professor Nelson Marmaroli. And we will open our session today with Dr. Hempel, who is currently Deputy Head of Department of Sensors and Modeling at the Leibniz Institute for Agricultural Engineering and Bioeconomy in Germany. Dr. Hempel is an expert in environmental sciences and sustainable agricultural practices. Her research focuses on developing innovative solutions to enhance energy efficiency and resource management within the agricultural sector. Dr. Hempel has a particular interest in the integration of technology and sustainability, collaborating effectively to promote environmentally responsible practices in farming. Her expertise and scholarship has contributed significantly to the advancement of sustainable agricultural methods, addressing the pressing challenges faced by modern agriculture. Today, Dr. Hempel's talk is entitled Advancing Dairy Farm Management, Leveraging Data, Neural Networks, and Interactive Web Design, which is part of the ET4D project from the ICT Agri-Food Initiative. Dr. Hempel, thank you very much for accepting our invitation to our webinar series. I'm going to stop sharing my screen now, so you can start sharing yours. Thank you very much.
So I hope you can see my slides now in presentation mode.
Yes, we can. Everything looks
Good.
great.
Then thanks again for the invitation and also for the nice introduction. So as already said, my name is Sabrina Hempel. I'm from the Leibniz Institute for Agricultural Engineering and Bioeconomy in Germany. And I'm the coordinator of the ED40 project, which is about environmental management and transparency in dairy farming. And today I want to present some key ideas and first preliminary results of our project, which is meant to improve dairy farm management through the use of data models and interactive web design. Sorry. Yeah, I think it's well known that dairy farming and the consumption of dairy products is related to sustainability in multiple aspects, including social, environmental, and economic sustainability. And here, particularly the environmental sustainability is pretty much discussed in the public, but also um, sorry, aspects of social sustainability related to, for example, animal welfare or food safety are in the focus of public discussion. Usually there are mainly the problems highlighted, and we think that one of the main reasons here for this rather negative view is that we have a lack of transparency and information flow along the value chain. So in principle, there is a lot of information available from farms. It is possible to use modern technology to measure environmental aspects. There are physiological measurements on farm, there are behavioral measurements, and also productivity measurements in general. This enables the farmer to control the housing environment. It helps also to give some early warning to better manage behavior, health, and reproduction of the farm animals. And it can help to control the management and productivity in general. On the other hand, for the consumer, there is less information. So usually we only have very general labels or we have initiatives from individual farmers. And that means that precision livestock farming can in general improve the efficiency of the system by optimizing the use of inputs. But the reality is often different because the precision livestock farming technologies are mainly adopted by the large farms because we have very high investment costs. And on the other hand, we have limitations in the range of applications. Most of the sensors has their own dashboards and interfaces, but APIs that are connecting different sensors are often missing, and we often also have only limited access to the raw data. In addition, we have the problem that in rural areas we are lacking sufficient ICT infrastructure, and this limits the data transfer and also the options for information sharing. So what the consumer sees in the end is that we have a global trend that the number of farms with few animals is decreasing with the benefit of large and efficient farms with intensified productivity. But this intensification often implies social concerns. Although this is somehow different among the countries, so there are countries with more smaller farms, and there are also countries with larger farms. And in the ED40 project, we want to address these challenges for dairy farming. And particularly here, we are focusing on aspects like environmental protection, efficiency and productivity concerns, and animal welfare considerations. In our project, we aim to further develop and validate an on-farm data management system with embedded sensors, together with an optimization of the data transfer. And we want to develop a web application to share the information from the on-farm system. We want to identify the information requirements of different user groups in order to design tailored reports. And we want to demonstrate the applicability of such a system on commercial farms under different climatological and socioeconomic conditions. Our project is now running for about 1 year with 11 partner institutions from 8 countries, combining the expertise from universities, research institutes, and companies. And you can see here that project partners are quite distributed across Europe. The project involves 6 work packages in total, and the first 2 are dealing with the collection and the transfer of sensor data. This sensor data is then further processed and shall be presented in an interactive web application, which is designed in the fourth work package. And here we also explore different data-driven modeling approaches in order to support a multi-criteria assessment of on-farm data. And we want to have a web application appealing to different user groups. So we use social diagnosis to tailor the data management system to the needs of the different user groups. And therefore, in the work package 3, we gather information on the perception and the information needs of the groups of farmers, consumers, and other stakeholders like milk processors, retailers, and regulating bodies. The other 2 work packages are more dedicated to ensuring project's impact and the smooth interaction of the activities. We have different sensor systems in use, which are strategically placed across farms in order to ensure a suitable data collection. And the central unit in our project is the so-called ED device, the Enviro Detect system, which is provided by one of our partners, Agroecosystems. And this is intended to be installed in 5 farms, collecting data about temperature, humidity, dust, and different gas concentrations and emissions inside the housing. In addition, there is a multi-gases monitoring system and a low-cost environmental monitoring unit, which are set up and tested in a barn in Turkey. And this is meant as an option, particularly for the very small farms. And finally, we have different sensor systems for temperature, humidity, air velocity measurements, gas concentration measurements, different gas concentration measurements, which will be in use in parallel to the Enviro Detect system in Germany in order to provide additional validation data. And in terms of communication infrastructure, we are focusing on wireless connectivity in order to ensure quasi real-time data transfer. And we do this with a 2-step approach. First, solving the issue of getting the data out of the housing system. And then in the second step, the connectivity of the farm towards some cloud system. So far, the Enviro Detect system is running more or less stable in 2 farm locations in Poland and Estonia, where we have a weekly data transfer. And we're currently in the process of installing the device also in Germany and in Israel. Different 2 other locations in Poland and Estonia might follow as well. And in the near future, we also plan to install the device in a farm in Hungary. In parallel, the first trial with the alternative sensor system has started in Turkey this summer. And we developed a methodology for assessing the cellular connectivity performance in different rural areas. And this has been already published as a master thesis. And you can find the link here below in the presentation as well. As I mentioned, engaging different target groups is one of the key aspects of our project. So by understanding the specific needs and concerns of each interest group, we want to tailor our data reports in the web application in the end, in order to make it most useful for each of the target groups. And in this context, we did different survey studies. So we started with one pilot study with 130 consumers from 7 countries, which was conducted this spring. And at the moment, we're running another survey study with 420 consumers. Early next year, then the studies with the farmers will follow, and we will also do in-depth interviews with the other stakeholder groups. So far, we have only the results from pilot study, and these indicated that the classical sets of factors like price, taste, brand, and composition were still the most important for the consumer decisions. but ecological and animal welfare related aspects were ranked on intermediate places by the respondents. And we suppose that the accessibility of the information related to the different sets of factors may have an influence here. However, this needs to be further explored. So, as I mentioned, both the sensor and the social data are only becoming available slowly now. So, in terms of the data management, I can only present the rough concept at the moment. So, our idea is that after pre-processing the collected sensor data, we want to use statistical and machine learning models, for example, long short-term memory or seasonal autoregressive integrated moving average models or some neural networks in order to predict housing conditions or production efficiency. And potential goals here of the modeling might be related to the improvement of animal health, the management of environmental loads, the provision of transparency of the production process in general, or also the correlation between environmental aspects and productivity aspects. But these goals need to be further specified in the course of the project based on the results from the social diagnosis. So what we have so far is that within our web application, we want to provide highly aggregated information that is available for everyone. And what will be shown here will be based on the results of the consumer surveys. The farmer shall always have the right to indicate and decide which of the information from his or her farm he or her is going to share. In addition, there will be dashboards that are personalized based on the different user group accounts. So each user can then access a certain set of dashboards with specific content after logging in. And at the moment in our prototype website, we have the option for login for farmer and one for a broader group of stakeholders. In addition, there is an option to upload additional data that is not automatically transferred to the data management system, but shall still be considered in the predictive modeling. So to summarize, the ED40 project aims to understand the information needs of different target groups along the dairy value chain in order to demonstrate the added value for farmers when sharing their on-farm data and to provide recommendations to optimize the on-farm communication ecosystem in order to just enable the data sharing. And in the end, we want to set up some kind of easy to use data space for the farmer to share data and information combined with some kind of multi-criteria assessment for different user groups as an interactive online application. In the future, we want to integrate more technology in the agriculture from the agricultural sector and making this its output understandable and meaningful to the different interest groups. So on the long term, we're aiming for broader implications that could then transform data-driven decision making on farms and enhancing efficiency and sustainability in general. And with that, I'm at the end of this talk, and I like to thank the support by the ICT Agri-Food in general and the funding from the Horizon 2020 Research and Innovation Program and from our national funding from the German Federal Ministry of Food and Agriculture. And I want to thank all our supporters at the Institute and from the project team and Bath, and also from the international partners and their respective funding bodies. And I'd like to thank everyone for their attention. And yeah, now I'm available for questions.
Um, Thanks very much, Dr. Bell, for such an interesting and very insightful presentation, I thought. I just want to take this opportunity just to remind our attendees that the chat box and Q&A section is open now. It's been shared with everyone, so please feel free to type your question. If you have a question for Dr. Hempel at any point, please do feel free to use both the Q&A section and the chat box. Dr. Hempel, just while we're waiting for people to type their questions, I was just struck just by a couple of like really interesting things. I mean, like the development of the web app is fascinating to me. And I wonder, can you just maybe tell us a little bit more about that? I was thinking particularly about, you know, the way in which the web app will facilitate like tailored reporting for farmers and other interest groups. And I was wondering specifically what kind of features, I know you touched on it a little bit in the talk, but I was wondering what kind of specific features would that web app include?
So it's not finally decided. As I said, it will be based on the results of the social diagnosis. But the basic idea is that for the farmer, we can, we just include different types of dashboards that are already available so that we just get the information that comes from the multiple sensor systems, which has their own dashboards, and we bring it together in one place. And then the farmer can decide, for example, he wants to share some information on the housing conditions, on the environmental conditions in the housing, like effects of temperature, humidity, affecting the animal welfare or gas concentration and levels, which might be below some standards. So the farmer can use this for advertising his or her way of farming, and you can just enable sharing the data, and then this is visible to everyone, so to the consumer in an aggregated form. So just comparing this way of farming with some standard or yeah. So that's the basic idea.
Fascinating stuff. And it just leads me to another question about I suppose, the kind of the practical implementation of that management system. You mentioned just about the kind of wireless connectivity and installing the embedded sensors in dairy farms across different geographical locations. And I'm imagining that presents challenges, particularly in terms of like wireless connectivity. I know in Ireland, it's, in rural Ireland, it's a really big major issue, and the government here is obviously taking steps to installing a dependable, fast broadband around. And I'm just wondering, kind of like in different locations across Europe, that probably would be a challenge, I assume, also to the project, like the challenges presented by the lack of kind of wireless infrastructure available in different parts of Europe for dairy farmers who are keen on implementing the system.
Yes, in general, you're right. We've actually found out that the locations that we so far selected are doing rather good in terms of the general wireless connectivity. There is this master thesis the which developed some kind of modeling approach, so you can put in some information from your location, and then you get an information of what is yeah, the expected connectivity. And in the next step, the colleagues are also working on giving yeah, recommendations how this can be improved. So for using cellular technology, for example. But we found out that at the moment the larger challenge is to get the data out of the housing system first. So the idea is that we will have an access point outside of the house, which is then, for example, connected via cellular connectivity, or in some regions where this is still not working, then satellite systems might be an option. But the real challenge is first this step from the house outside to the access point. And just to follow all the regulations, so you're not allowed to totally amplify your your signal under using certain bands, and so there are some options, yeah, to just connect this indoor to outdoor. And here at the moment, it seems that it's probably easier to have one access point inside that is connected with a wire to the
Mm.
outside access point, and then we're just we're having this border which we can cross with the wire, which might be probably easier, but that's currently yeah, work in progress where the colleagues are working on.
Excellent. Thank you very much, Dr. Hempo. Fascinating stuff. I'm just kind of wondering also about like the engagement with farmers. Like, have you got a lot of feedback from farmers and other stakeholders with regards to their kind of need and kind of want for the implementation of such a system?
Well, so far the real farmer service haven't started yet, so we're just in contact with the farms where we are
Brilliant.
running the trials. But from there, so the main feedback was that they want to have some information on, for example, electricity use, so how they can optimize the indoor environment with reducing costs and for electricity use, for example, or improving the animal welfare with less input of energy, or so this might be potential aspects where we could help the farmer. But as I
Yeah.
said, these surveys will just start beginning of next year. So then
Ah,
hopefully we will learn more about the actual needs of the
okay.
farmers.
Yes. Dr. Hempel, we're just coming up on 9:30. I'd just like to say thank you very much once again for your excellent presentation and really, really interesting project. It's just fantastic this morning to learn about the ET40 project. Um, I think now, if I could ask you maybe to stop sharing your screen, please, and we'll move to our next speaker.
Thank you.
Thank you very much, Dr. Hempel.
Aspetta che lo dica lui, i soldi di
Now, joining us is Professor Nelson Marmaroli, who is currently Professor Emeritus in the Department of Chemistry, Life Sciences and Environmental Sustainability at the University of Parma in Italy. Professor Marmaroli is a distinguished professor at the University of Parma, specializing in environmental biotechnology and microbiology. With extensive experience in research and teaching, he focuses on the sustainable management of natural resources and the bioremediation of contaminated environments. His work emphasizes the application of microbial processes to address environmental challenges, contributing to advancements in sustainable practices. Professor Marmaroli is committed to fostering innovation and collaboration in the field of environmental sciences, aiming to promote a more sustainable future. Today, Professor Marmaroli's talk is entitled Connecting Sustainable Agroecosystems and Farming with Circular Bioeconomy and New Technologies, which is part of the Connect Farms project, also from the ICT Agri-Food Initiative. Professor Marmaroli, thank you very much for accepting our invitation for our webinar series. We're really privileged, I think, to have such a distinguished speaker with us today, and two such distinguished speakers, I might add. So without further ado, the floor is yours. I'm going to stop sharing my screen and you can start sharing yours. Thank you very much.
Okay. Just a moment, please. We are trying to get ready with the presentation.
That's okay, no problem at all.
Okay. Can you see now the
Yes, we can
presentation?
see the slides, and if you just, yes, it's in full presentation mode. Excellent.
Okay. Thank you very much. And good morning, everybody. And I'm here today to present this connecting sustainable agricultural system and farming with circular bioeconomy and new technology, which is a project financed by Eranet that fortunately also has found the support also of other national and regional funding agencies since its interest. I want to first of all to thank the financial agency because to avoid the risk of forgetting at the very last and to mention the financing agency for this. So thank you very much for this to the financing body. I would try to make my presentation very informal in order to avoid as much as possible too much technical jargon, to make it more accessible also to non-specialized or differently specialized people attending this presentation today. This is the way to go. Yes. I am today assisted by my colleague. I want to see.
Hello, everyone.
Dr. Marina Caldara, who is helping me to coordinate the part of the project that we are carrying on in Parma. And also I want to acknowledge the real and the important work of this cooperator. To this project participate different European countries, Bulgaria, the Agricultural University of Plovdiv, Lithuania, Agriculture and Forestry Lithuania Research Center, Estonia, University of Tartu, Spain, SMART, Poland, Warsaw University of Life Science, Turkey, is very difficult for me to present, and to say Italy, the University of Milano, and the University and Cinza, and the University of Parma. So I want to also to acknowledge the cooperation and the real and the stellar effort that all these participants contributed to the realization of this project. First of all, I will give you a very short outlook of the project in terms of general structure and content of the different work package. And then I will give a presentation of some of the main results that symbolize the achievement and the interest of the project. Of course, I will not be able to present all the data, and the data will be only a very short compendium of the work that is being done in the different countries. So one characteristic of this project is, as far as I know, that this project accumulates in the same body both research on the plant sector and research on the animal sector, which is not common as far as I know in European projects. I find this a very interesting challenge also for the project to put together these two different interests that frequently remain apart. This project is organized in 6 work packages. The first work package is on the biochar and development of novel amendment, starting from agricultural residue, both from plant origin or animal origin. From this, the biochar produce, different type of biochar produce, and the different amendment amendment will flow into the crop, food, and feed system to test if they really produce something which may be interesting for the innovation of this cropping. And to this work package also will flow also integration from residual of animal origin coming from livestock farm, which is the subject of the work package number 3. Of course, the work package number 3, livestock farming, is also in strict contact with the work package number 1, with because it will benefit of biochar produced from vegetable residue, but also will give to biochar production residue from the livestock farming. These are the more 3 technical and scientific work package. And that is also a 4 work package number 4, which is dedicated to precision farming, considering all these aspects in the philosophy, of course, of precision farming and precision agriculture. And this all the information coming from the more technical work package will go to the evaluation work package. The goal of this work package is to evaluate the circularity and the sustainability of this operation. And of course, there will be an umbrella on all these work packages of coordination and dissemination. So this I give you all a visual idea of the different material, both of plant and animal origin that we are dealing with during the project. Biochar, plant, and different sensor, proximal and non-proximal sensor, livestock farming, monitoring and determination of precision agriculture and the sustainability of our operation. A very interesting characteristic of this proposal, as you can see from this slide, is the integration between a very strict scientific and technological part with a more socio-economical and sustainability, circularity aspect, which is more relevant for which is, let's say, extremely relevant for the development of new agriculture and new agricultural practice. The work package number 1, as I said, is dedicated to the production of amendment and biochar from agricultural residue from plant and animal origin, obtained locally, but integrating them in specific European context, evaluate the soil functionality after the treatment of the supplement with this amendment and biochar, the physical chemical property, the carbon stock realization, soil organic matter quality modification and implementation, and effect on soil health. Work package number 2 is to identify barley line suitable for poultry nutrition and characterized by reduced leaf chlorophyll content, able to better adapt to climate change. Test novel rotation scheme, compare soil amendment with the usual mineral fertilization, tradition used to identify the most suitable one. Evaluate the effect of different intercropping system and monitor the crop performance and effect of treatment on biodiversity of pests and beneficiaries. Biochar production from residual barley biomass will be used also in that next work packet number 3. This is another characteristic of this proposal, to integrate genetics with other technology and with the more socio-economical part. The work packet number 3 is to test biochar, of course, produced in WP1 on poultry litter, test biochar produced in WP1 on dairy sheep manure, test barley grains with different content of beta-glucan for their nutritional property, demonstrating that biochar can be used in dairy sheep feeding by acting as an electron mediator at gut level, inducing several redox reaction that could take place more efficiently, increasing in turn the feed intake and nutrient efficiency. Now, if you let me stop a little bit on this point, because I believe this is very, let's say, interesting, because we are used to hear that biochar is produced to amend soil for vegetal crop production. This is a new interesting alternative because biochar is produced also for vegetal residue to feed animals. This is a novelty, I believe, and a very interesting and important novelty because it makes out of biochar a very multifunctional product with different exit and different outputs, both in the vegetal world and also in the animal world. It is interesting to remind that under certain conditions of safety, of course, biochar is used also for human feeding as a medicinal, more than medicinal as integration of diet. So the work packet number 4, the objective is to install sensor to obtain the relevant soil, crop, and animal parameter with special attention given to the greenhouse gases, emission, and the use of proximal and remote sensing data for precision farm. In the picture, you have some of the proximal sensor employ the soil sensor, plant sensor, captiometer, IP, hyperspectral camera, field spectrometry, and so on. Characterize and monitor the crop cultivation and the animal husbandry with site-specific sensor and automated data retrieval technique using GPRS technology. Receive, prepare, and process data in preparation for the data management and modeling carried out in WP5. And work packet number 5 objective is to evaluate soil and crop quality, nutritional quality of the feed, animal product, and production intensity, develop a unified result database from the system, soil, plant, livestock, environment, perform life cycle analysis and ecosystem service evaluation of the proposed solution in view of EU policy and compliance with the circular economy. And oops, sorry. And I will stop here to the work packet description and go to the explanation, presentation some of the data, more data that we obtained as an exemplification of the achievement of the project. So identification of the more suitable amendment treatment, which one of the core elements of the project. Amendment characterization. We developed and produced different type of amendments that we characterized chemically, physically, and biologically. When I say biologically, I mean characterization of the biosafety of this novel amendment with germination test, ISO germination test, so standard germination test, and also standard phytotoxicity growth test. By the occasion, we also developed a mutagenic test to determine eventually the mutagenicity of these novel amendments using modified Ames test. Test on plant, and then the amendment were characterized on growing plants, measuring chlorophyll content, effect on chlorophyll content, stomata resistance, image of thermal camera to determine the evapotranspiration during the day, and post-harvest on the number of fruit, number of branches, ripeness of fruit, green production, average weight of fruit, weight of rotten product, apical rotten, and different other parameters connected with the fruit quantity and quality. We also determine fruit quality at the level of the molecular content in terms of useful molecules present in the products. This is an example of one of these tests. This has been made on tomato, but we were not working on tomato only, but also barley and other cereals. But we are presenting, for simplicity now, the data on tomato, because tomato is a very interesting fruit that can be characterized, and the evaluation of the tractor growing condition with and without the novel amendment, or without and with biochar, can be determined quite easily. Different maybe from which the seed are very tiny, and the variation and the composition of this seed are not so easy to evaluate. So this is the parameter that we were measuring, and the chlorophyll content on the right side of the slide, you see the number of the different conditions. In particular, I point your attention to the number 3, which is plants treated in the soil with biochar, and the condition of maybe number 5, the soil added with poultry litter, which also contain an amount of biochar, because biochar was also added to the litter of the poultry. As you can see, there is two significant variation in respect. There is some significant variation in respect to the control without addition, demonstrating that these treatment influence the photosynthetic activity of the plant. This come particularly interesting when we go from the growth of the plant in terms of physiological parameters to the production of the plant in terms of harvest and commercialized product harvested. As you can see in the yellow part of the slide, you can see that the number 3, which is tomato grow with the presence of biochar, the production of the commercialized products increased significantly. And this significant increase is determined by a very important fact. It's not an absolute increase, but the increase is in the term of products not affected by disease. So rotten or ripened and so on. So the effect of biochar is not on the gross production, but on the commercialized production, which is the one that interests the farmer, by the way. We also analyze several enzymes on tomato fruit that characterize the quality of the fruit: peroxidase, catalase, GSH, and so on, phenolic content. Tomato is important food for human diet, also for the phenolic content and antioxidant property of the phenolic content, ABTS and DPPH. And also, I point to the column number 3 again. With the addition of biochar, there are significant increase in this beneficial component of the fruit, as well as in the proline content, with underlying a significant increase in tolerance to water stress. Proline control, in a way, also the resistance of tomato, but also of other plants to water stress. And tomato is particularly requiring in water. So an increased tolerance to water stress makes this culture more sustainable, because it will require less water. So what is the best amendment to conclude? We tested different types of amendments, in particular biochar, but also other amendments of an animal or plant origin. In particular, we were focusing our attention on biochar. Biochar because we can flow into the technology of biochar residue coming from the animal side and also from the plant side. But not only, residues that are difficult to deal, to treat in other way. And this way make the production of biochar, this technology, pyrolysis in particular, extremely adaptable and flexible to this condition. Pyrolysis is a multi-purpose technology because it does not produce only biochar. Biochar is produced with an amount of between 15 and 30% of the raw matter introduced into the system. The rest is in terms of syngas. Syngas is can be used as a source of steam for energy purpose, but syngas with with the modification of this technology can be transformed also in let's say mm, well, excuse me, I forgot the name.
Hi, Professor Marmaroli. I think your screen might just have frozen on us. Are you still with us? You're back. Yes, that's good. Sorry, your screen just froze for a minute. It's okay now.
Okay, sorry.
It appears to be
Yeah,
okay.
there
No
are,
problem.
yes. But in the transformation of a residue in biochar, we have to consider the fact that there is a particular situation that accumulate the type of residue and the type of biochar produced. So there is a singularity in the production of biochar from agricultural residue that has to be considered. In other words, every type of biochar produced from a source of uh, agricultural residue has to be subjected to an evaluation, a risk evaluation, a risk analysis. And this is an example that we have produced in a recent paper of all the conditions that we propose must be considered for this risk analysis to constitute a risk metric for safety assessment of plant or animal-derived biochar. We recently developed also another type of biochar that came not only from plant residue or from residue of animal growing, but directly from meat and bones of animals. And we call this bone char. There is a very basic difference between classical biochar and bone char, which overcome one of the difficulty in the application of to agriculture of biochar, which is the cost and the purpose. Classical biochar is an amendment. It doesn't not provide nutrient to the soil, but only physical support to the consistency of the soil. Bone char is a fertilizer also because it contains nutrient and in particular phosphate. And if there is something that modern agriculture is hunger, is phosphate. You cannot find phosphate anymore for agriculture in the world. It's very costly. So there is an evolution also in the production of this new amendment, from amendment, simple amendment, also to fertilizer. And I thank you for your attention, patience. Thank you very much.
Professor Marmaroli, thank you very much for such an interesting and extremely insightful presentation. I think your elucidation of the project was really excellent. Thank you very much. We just have a couple of questions from our panelists and attendees. Two questions actually from Dr. Empel, and perhaps you may have slightly kind of addressed the first question over the course of your presentation. Dr. Empel was wondering about the initial results from the project, particularly in relation to results concerning how much the feed intake and nutrient efficiency can be increased when feeding sheep with biochar. And the second question she has is,
Yes.
are there any effects on methane release during rumination as well?
Can you repeat the second question, please? There is no effect on that?
Sure. So the second question was, are there any effects on methane release during rumination?
Okay. So the first question was if there are effects on feeding biochar on the well-being of the animal in general. Okay. The effect, there are effects, and the effect that we have measured and evaluated were all positive, because the presence of biochar, both in the litter and in the feeding, made the general environment more healthy because of the absorbing capacity of biochar outside the animal, but also inside the animals. Okay. This is the main action of biochar in the stomach. Of the monogastric, coming to the second question, but also the digastric. And it does not interfere with the life of the gut microbiome. The gut microbiome is not affected because biochar is not toxic to the gut microbiome. On the contrary, it protects the gut microbiome because biochar is a nanostructured material made of small pores of the dimension a little bit above the dimension of the microorganism of the gut. So the microorganism can house into this pore, multiply, work in a protected environment, instead of being completely exposed to the gut environment, which can be normally stranded, but not always, due to environmental condition, feeding, disease, infection, pathogen, pest, and so on. So it is very interesting because what biochar does outside in the environment, the same biochar can do inside in the gut environment of an animal. So I believe I answered to both questions.
Very good. Thank you very much, Professor Marmaroli. Just time for just one final question from
Yes,
our
please.
audience. So one of our attendees is asking, Professor Marmaroli mentioned that as part of the project, a mutagenicity test is performed on the plants grown in biochar, if I understood correctly. Can you please expand a bit on the methodology?
Excuse me, the mutagenicity test is done on the soil added with biochar or amendments, not on the plant. It's done on the soil, using salmonella as in the Ames test. So the ratio is this. In the soil, especially around the roots of the plants, there are the leaves, the root microbiome. This root microbiome is made of prokaryotic and eukaryotic monocellular eukaryote mostly. And these may be very sensitive to mutagenic agent. And the test with device for is a test for mutagenicity in microorganisms, Ames test. So we extract from the soil and we tested the extract in with the Salmonella typhimurium Ames test configuration. Is it clear now? Is it more clear?
Yes, I think that's very clear, Professor Marmaroli. Thank you very much. I just see, I'm just keeping an eye on the time, and I just see that we're rolling up nearly 10 past 10. So I think we'll just
I
unfortunately have to
apologize.
wrap it up. I think there could be so many more questions. It's such a fascinating study. Um, Thank you very much, everybody, for your questions and for your attendance and participation. I would like to thank once again Dr. Hempel and Professor Marmaroli for giving us such wonderful and insightful presentations, and I think providing us with a really fantastic overview of their respective projects. So our next webinar will be on November the 21st at 10 a.m. Central European Time, and I'm going to be sending out those invitations to all of you in the following days. So once again, thanks very much to our panelists today, and thank you for attending. I really hope you enjoyed the webinar and hope to see you again soon.